Hello, greetings, welcome back. In this class we are going to look at Poisson distribution. Oh, sounds interesting. Poisson. Yes, so what does Poisson distribution model for us? It is working with some intervals and outcome of those intervals. For instance, we are dealing with at what rate of something happening. For example, in queue modeling at a bank or at any other service delivery, it is important to know Poisson distribution to model how long it will take to serve a customer, how many people are in a queue at a certain time, and so on. It deals with frequency in which an event occurs in a certain interval. That is what we have already said. And for Poisson, we say this is the notation P O for Poisson, and given lambda, which is the rate at which something is happening. So when we say X follows Poisson distribution, lambda equals to 4. Poisson lambda equals 4. That is how we read. Let's take an example very quickly. You usually get 4 inquiries for your service in a day. Yesterday you got 7 inquiries. What is the likelihood today you get 7 inquiries? So how can you solve this? To solve this, we have to look at Poisson probability mass function for Poisson. So probability of y is equal to lambda raised to power y exponential, this is y, exponential raised to minus lambda, and we divide this by y factorial. Alright, this is this exponential is what we call Euler's number or Napier's constant, which is approximated as 2.72. Right? As quickly. You can now insert this in your formulas in Excel or in any software that you are comfortable with, and get the value. So lambda is the frequency that you are used to. So it is 4 raised to power y is now 7. 4 raised to power 7 times exponential of negative 4, and we divide this by 7 factorial. If you do this, you will get a result of 0.06. So the probability of someone will going to inquire for your service today, 7 of them coming to your service or seeking for your service, will be 6%. So this is a small, very insignificant probabilities that you are expecting 7 numbers. So in this case, you are going to save on the number of customer services. You can give them another task to handle today because you are not expecting as many as yesterday. Maybe the inquiry for yesterday has been pushed by some external forces, but you have to again look at your data and see what might have incited people to call you 7 times, much higher than the 4 you are used to. So that is how we calculate Poisson distribution in a nutshell. So in our next class, we are going to look at briefly introduction to continuous distributions, but we have to know how to do all this by software, because we have already known where they are applicable, how they get applied, and so on. So the next thing that we have to be bearing in mind is to apply this in different software if you're comfortable with Excel, if you're comfortable with R or Python. Thank you and see you in the next class. Enjoy learning.